Okay, so today we're going to do 7.2 on similar polygons. And so continuing on with chapter 7. So first let's look at a definition. Similar. Similar polygons are basically two polygons that have the same shape, but not necessarily the same size. And for these polygons, they can be triangles, quadrilaterals, pentagons, so on. All right. What we want to make sure with similar polygons is that all the corresponding angles are congruent. Okay, so you can kind of see the two pictures below of quadrilateral ABCD and quadrilateral WXYZ. Each of those angles, the corresponding angles, are congruent to each other. The other piece we have to make sure of with similar polygons is that the measures of the corresponding sides, so the corresponding sides, must be proportional. In other words, they must have the same ratio. Okay, so when we compare, like for example, if we look at AB is 15. That's going to correspond to WX, right? So AB over WX. So we look at that ratio. That's going to be a ratio of 15 over 5. Then we can compare BC has to compare to XY. And we have 12 over 4. We have CD or DC and YZ. Those are in a ratio of 21 to 7. And lastly, we have AD is 18, and that's going to correspond to WCZ, which is 6. So looking at all of these ratios, notice when we reduce it, everything ends up being 3 over 1. Okay, if any one of these sides came out to something different, then they would not be similar. So we want to make sure that all the corresponding sides are proportional. Scale factor. Okay, so that's basically the ratio of the corresponding sides. So when we looked at this last example here, the scale factor for quadrilateral ABCD compared to quadrilateral WXYZ is 3 to 1. Of course, you can write it as a fraction. It doesn't matter to me. Okay. Now, if I want to make note about one thing, and that's the order that I ask for the scale factor. So whichever one I list first, that has to be listed first in the scale factor. Because if I had asked instead, what's the scale factor of WXYZ compared to ABCD, that scale factor would be 1 to 3 instead of 3 to 1. Okay, so let's determine whether the pair of polygons are similar. And then if so, we're going to write the similarity statement and the scale factor. One quick thing I forgot to mention about the similarity statement. It's kind of like a congruent statement, but for similarity, we just use a squiggly line. So you'll see here. So it's going to be ABCD similar to WXYZ. We have to make sure that the order matches, just like when we had congruent polygons. So if A is the first letter, it's got to correspond to its congruent angle, which would be W, and so on. Okay, so let's take a look. Here it looks like we have two polygons. Well, first of all, we can see all the angles, all the corresponding angles are congruent. So all corresponding angles are congruent. So that kind of, we don't really have to do anything else there. We don't have to show any work. Let's compare the sides. So let's see, AB has to compare to EF. So if I have 3 over 9 halves, I'm going to take that, and remember, when we divide by 9/2, we're going to multiply by the reciprocal. Think of that as 3/1 times 2/9. And that is going to give us 2/3. Okay, so of course we can see CD compared to GH is also the same, so we don't really need to check that. Here, let's compare BC to FG. So 4/6, that's 2/3, which is exactly what we wanted. And then of course comparing these sides also is 4/6, which is 2/3. So yes, they are similar. And so you can put parallelogram in front, or you can just make sure the order of the letters is matching. So we'll say A, B, C, D, squiggly line for similar, and then we'll say E, F, G, H. Again, making sure that the order of the letters matches. Okay, B. So again, what I want to do is compare the angles, okay, so I can see all the angles are congruent. Okay, I should say corresponding, because they're not all the same. Okay, and let's just start out. Let's see. 6 has to correspond to 3, so that's going to be a ratio of 2:1. Oh, and I just realized, I'm sorry, I forgot to put the scale factor on the last one. Let me go back here real quickly. The scale factor is going to be 2:3. And just make sure when you're writing the scale factor, it's in the order that we write the similarity statement. So I listed A, B, C, D first. That's the smaller one, so that's 2:3. Okay, sorry about that. Now back to this other one. So we did 6/3, so that's 2:1. We got 12/6. And listen, this is a really easy one. You can probably just look at it, and you don't have to really go through this process of showing that each and every one are going to have the same ratio, especially something like this where the numbers are really easy. So I don't need to see all this work, but here I got 2:1. And lastly, 7 to 3.5. Yes, that's also a 2:1 ratio. So we have all 4 sides. So our answer is yes. We have A, B, C, D is similar to, and then I'll put it E, F, G, H. And our scale factor is 2:1. Okay, let's take a look. Example 2. So each pair of polygons are similar. We want to write a similarity statement, find the value of x and the measure of any indicated sides, and also the scale factor. Okay, so basically we know that these have to be similar. We're told that they're similar. Okay, so let's take a look at our similarity statement. So I have triangle. Let's do ABC, similar. So that's going to have to be DEF. Now, in order to find the scale factor, I just need to make sure I have 2 pairs of corresponding sides that I know. So the scale factor is going to be 27 to 18. Notice I said write the scale factor of the polygon on the left, the one on the right. So that's why I did 27/18. And when we simplify that, we're going to get 3/2. So 3/2 or 3:2. Okay, now in order to solve for the value of x, this is what goes back to the last lesson, which was on proportions. So we just want to make a proportion So I'm going to compare 21 over x. 21 over x equals 27 over 18. Now, since we already reduced the 27 over 18 to 3 over 2, you can do that. You can replace it and then cross multiply. That's fine. Or just leave it like this. And we'll cross multiply. We'll get 27x equals 378. Divide both sides by 27 and we get 14. So x is 14 and df is represented by x, so that's just going to be 14 there. Okay, next one. Again, we know that these are going to be similar. So let's first look at putting it in order. A, B, C, D. Similar to, now just be careful, this one isn't drawn in the same kind of direction. So if I started with A, that matches with E. B matches with F. And of course it goes in nice alphabetical order, not always like that, but I just want to make sure. Okay, this time, before I find the scale factor, because if you look at the sides that we know these three sides, 10, 14, and 16, but I don't have any measures, so I can't find the scale factor just yet. I actually have to solve for x first. So let's take a look. How could we solve that? So first of all, let's look at x minus 3. X minus 3 has to correspond to 10. How do I know that? Well, one is I could look at the angle markings, like that x minus 3 is between the one that has 1 and 4 arcs. And over here, same thing. Also, since we did the similarity statement, I can just look at the letters. So like E and H are the first and last. So it has to match with A and D, which are the first and last letters there. So 10 corresponds to x minus 3. Then the x plus 5, okay, so that's EF, that has to correspond to AB. Again, you can look at the angle markings that are between, or look at the order of the letters in the similarity statement. So I have 14 over x plus 5. Now, that's not the only way to set up the proportion, okay? You can do, you could do x minus 3 over 10 equals x plus 5 over 14. That's fine. Some of you might even ask, well, what if I did 14 over 10 equals x plus 5 over x minus 3? These are all fine, okay? I just like to, when I set up my proportion, I always compare corresponding sides. So you don't have to do the one on the left and then the one on the right. It depends on how you'd like to solve it. Okay, let's go ahead and cross multiply. All right, so I get 14x minus 42. Don't forget to distribute. And then we get 10x plus 50. Let's see, subtract 10x from both sides. Go ahead and add the 42, so I get 4x equals 92. And then we get x equals 23. Now, once I know the value of x, I can figure out, for example, EH, so that's going to be 23 minus 3, so that's going to be 20. FE, so that's going to be 23 plus 5, so that's going to be 28. And then I have to find GF. Okay, so what I'm going to do is I want to figure out this length, which is going to correspond to this side. So maybe I'll introduce a new variable. I'll use y so I don't get that mixed up with the other ones. So I know 16 over y has to correspond to any other two sides that are corresponding now that I know them. So maybe I'll use the 10, and remember 10 compares to 20. And then cross multiply. And what do we get? Well, again, you can actually recognize, what do we notice about all these numbers, right? 10 becomes 20, 14 becomes 28. You can even see easily that each side is twice the length of the smaller one. So this is going to be 32. So GF is 32. And then the scale factor, again, you can see, you know, if AD is 10, and that corresponds to EH, which is 20, that's going to be a scale factor of 1 to 2. Again, comparing any two corresponding sides, and we can find that. Okay, so next we're going to just look at perimeter of similar polygons. So basically, if we know two polygons are similar, then their perimeters are proportional to the scale factor. So basically, the ratio of the polygons, or the ratio of the perimeters, is going to be exactly the same as the scale factor. Okay, so for A, we just want to solve for X and Y. Okay, so first we'll start with X. So X corresponds to 3. And so I know X over 3 has to be equal to 6 over 4. Again, you could have done 4 over 6 equals 3 over X, and so on. Here we get 4X equals 18. So we divide both sides. So 18 over 4, that's just going to reduce. That's going to be 9 over 2. And then I have Y plus 1. That's going to correspond to 8. So Y plus 1 over 8. Okay, and since I did the Y plus 1, I'm going to put 4 over 6 this time. And I'm going to cross multiply. So we have 6Y plus 6 equals 32. So we'll get 6Y equals 26. And divide, we'll get 13/3. And just leave it like that. Don't try to change anything to decimals. Okay, what is the ratio of the perimeters of polygon RSTUV compared to ABCDE? So I am going to look at one side from this polygon. So I'll use 4 since I already know that. And that's going to compare to one side in ABCD, so I'm going to use 6. Remember, ratio of the perimeters is exactly the same as the scale factor. So I'm going to get 2 to 3. So if I had asked for the scale factor, your answer would also be 2 to 3. Now, if the perimeter of RSTUV is 20 centimeters, what would be the perimeter of ABCDE? So one of the reasons this is helpful, right, knowing that the ratio of the perimeters is the same as the scale factor. Notice I don't have any information about these other sides here. I don't have enough information. I can't solve for them. But if I know the ratio of the perimeters is 2 to 3, and I know RSTUV has a perimeter of 20, I can find the perimeter of the bigger figure, or the bigger polygon. Okay, go ahead and cross multiply. We get perimeter is going to be 30, and that's centimeters. So ABCDE has a perimeter of 30. Okay, last one here. Almost done. So we have two triangles that are similar to each other with a scale factor of 3 to 4. So we know the lengths of sides TUV are 4, 6, and 8. What are the lengths of the sides of JKL? So I'm just going to draw. You don't need to draw it, but sometimes it's good to visualize. If this is JKL, and that's similar to TUV, and we know the sides of TUV are 4, 6, and 8. Now I didn't specify which ones are which, and it doesn't really matter because ultimately we just need the lengths of the sides. So again, if we know the scale factor is 3 to 4, okay, I can find each side. So let's say I want to find this side here, JK. So I can do x over 4 equals 3 over 4, because that's my scale factor. And of course, cross multiply, or you can just kind of recognize x has to be 3. So one of the sides is going to be 3. Next, let's say we want to find this side JL. So I'll just call that y for now. So we know y corresponds to 8 and also has to have a ratio of 3 to 4. So that's going to make y equal to 6. So this side is 6. And lastly, we got to find KL. So we can call that z. So z corresponds to 6, which is a ratio of 3 to 4. Again, we're using that same one. Now this one I'm going to cross multiply. And when we divide, we get 9/2. So what are the lengths of the sides? The sides are, oh, and we're given centimeters, so I'm going to include units. 3, 6, and 9/2 centimeters.